Hey.
Are you saying hello with your eyes?
Exactly. Just checking. Doesn't work. Okay.
I want to get something out of the way. First thing right up top.
Okay, go for it.
We did a bad job of choosing the episode.
No, we
this
didn't
week.
do a bad job. You did a
No?
bad job. I'm throwing you under the bus here. I would have done the worst job, but it fell on you to correct it into a bad job. So,
Here's the story. When we're trying to plan all the different system design choices months ago, you had 8. We had 8 in the miscellaneous section, and like that won't do. 8 on one show is not okay. So it's like, okay, how can we split these up? And at that time, it was like months away. And then I like, this is good enough, specialized templating, and we'll figure it out closer to time. And then it got closer to time and we forgot. I forgot. We forgot. Whatever.
it's still probably, it's not worse than my idea, which was, okay, let's split it into miscellaneous 1 and miscellaneous 2.
So what we have is all the technologies today are, I think, they'll correct me, I'm sure, if I'm wrong. I think they're all developer facing, and they're all helping to separate developer knowledge from operational knowledge. They're all hoping to make it more simple for the developer.
Probably. We don't know. We'll find out. That's the goal of this episode. We'll find out. They will tell us. Whomever said that Victor, you're an idiot first wins.
Victor, you're an idiot.
You're not competing with me.
I'm going to have a 6th choice at the poll.
Yeah, exactly. There is no project below your name. Yes.
Also, there's Dapper next week that does the same thing too. So my logic's a little bit flawed already. We're doing our best. That's true. So we have a lot to cover this week because we have 5 projects on the show, each giving a 5-minute presentation. And then also we're going to do a demo from 2 weeks ago, which was when we talked about the one-shot actions, or what did we call it? Glorified cron jobs with a graphical user interface.
Yes. But so when you present, people were not really happy when I called them one-shot actions, but when I give a longer explanation, like glorified cron jobs with web user interface, all of a sudden the interest for one-shot actions increased. You just need to present people with a worse alternative, and then they're happy.
That logic you've already used it with miscellaneous 1 and 2. It's like, oh, specialized templating maybe isn't that bad.
There you go.
The pattern. Thanks everyone who's saying hi in the chat. So let's talk. I guess I don't want to fully recap one-shot actions, but who won that one? Let's talk about that. So because we're going to see a demo. Do you want to just go ahead and demo it?
Yeah. I mean, who won?
Argo Workflows.
There we go. Yes, it won. Put my screen on, Whitney.
Yeah, it's on.
Let's demo it. Yes, no time to lose. This is my screen, right? You can see my screen. Cool. Here is a definition of Argo Workflows, one that I'm using it in this demo. It's a nightmare. It's a long one. I'll try to be very brief. It's a workflow. It's a Kubernetes resource, right? It presents what people call CI. It attaches some volumes to have credentials for the registry, where, among other things, we'll be pushing images. It's some volume claim templates. This is the work there. This is how the state of one task will be persisted to the other task, because different containers still need to access files from each other. And some parameters. This is the repo. This is the registry, and so on and so forth. Parameters. Every single tool of that kind has it. And then starts the real deal, right? This is the DAG, meaning that it will construct the order in which things should be executed depending on the dependencies that you will see later, right? And now, tasks themselves, in no particular order, so ignore the order here, is, okay, we might need to check out the code. We need to generate some tag. We need to build some image, and so on and so forth. All those are using templates, right? So this is just how we invoke some tasks defined somewhere else. And some of those have dependencies like, hey, I'm not telling you when to run this task. You can run it whenever you want, but it cannot be run before you finish generating tag and running unit tests, right? And through those dependencies, it will design DAG or tree-like structure when what needs to be executed. So in other words, it will not execute it in order as it's defined here. And then further on, we have those templates. If I ever find them,
Is
here we
that
go.
an acronym?
Yes. I don't know what it stands for. And some of the guests, I'm sure that there is DAG in one of the tools that will be presented there. You get extra 5 seconds of your 5 minutes if you explain if you tell what the DAG acronym is. Data, there is data there, something probably. I don't know. And then we have those templates, right? Those are that we invoked before. Hey, if you want to execute something called git checkout, then run this script. And this script is going to use this image, and it will work in this directory, and the command is going to be to sh and then execute whatever, right? So basically, this is conceptually very similar to what you would do in Jenkins, what you would do in Tecton, what you would do in GitHub Actions, slightly different syntax. But it all boils down to those are the tasks, those are the dependencies across those tasks so that you can construct the order in which things are running. And the tasks are, in my case, not necessarily in all cases, just to be clear, just execute those commands, right? I have scripts or commands, run them, and that's about it, right? So that's a quick one, no time to lose. Stop me, Whitney, if I'm too fast or anything like that. So what I'm going to do is, I'm not going to even show you the web UI. No time for that. There is a web UI. It has a lot of colors. It's pretty. It's beautiful. All that stuff, right? I'm going to run it directly here. I could have set it up to run by receiving a webhook request from Git or whatsoever. But for now, I'm just running it manually. And now it calculated the first 2 steps, right? Check out the generate tag. And once it's finished with those, it will figure out what to run next, and it will slowly execute all the tasks that are specified there. Now, this will take a few moments, or maybe more than a few moments. Yes?
DAG stands for Directed Acyclic Graph. Our guest Ben put that in.
Okay, so with such a silly name, how can you blame anybody not remembering? Come on, acyclic.
I thought it was... What's that even mean?
Yeah, kind of like...
Not.
I mean,
not
show me a
cyclical.
company that will sell anything after being called acyclic.
I thought like DAG was maybe like something you said because it's so awesome. Like DAG. That's cool.
No. It's DAG because I mean, ask me tomorrow. I will forget to again acyclic. Anyways, while we're waiting for this, it will take a while, and we have no time to lose. I'm going to switch to the next choice for the next week. We had what did we have?
Wait, you're jumping ahead.
Yes.
It doesn't have to be a sprint this time. It's not a conference talk. How about we let that run and we properly talk about last week.
So I can speak slowly and take my time, and nobody will complain that we're 40 minutes into the show without bringing the guests. Not happening, Whitney. I don't care. Listen, this will take 5 more minutes or something. We're jumping to the next section, right?
Yes. And we'll
say
come back
whatever
to
you
it.
wanted to say for the next section.
Yeah, I want to talk about I want to talk about graphical user interface and why do we need to add in our platform at all?
Because people like pretty cool. Okay, so I came up with a new explanation. I think that people like graphical user interfaces because they're all Windows refugees.
Oh, yeah?
Yeah, they come from Windows. They're used to clicking stuff. And then they're thrown into Linux servers. And it's horrible. And you need to show people some feeling like home. Lots of colors, buttons, stuff like that.
So are you saying it's not a mandatory part of a platform? It's just...
No, it's definitely not I mean, the only mandatory by today's standards in my head is API, right? So what is the mandatory part of AWS? AWS is a platform, right? The mandatory part is API. Now, on top of that API, you can have a console like Web UI, you can have a Visual Studio Code extension, you can have a CLI, you can have many ways to interact with the API, right? And definitely people, 100%, I'm sure of that. People want and they expect and they want Web UIs. So it's always there, but it's not mandatory.
So every tool already has its own web UI. Like you just said, Argo Workflows has a web UI. Crossplane
Not every tool
doesn't have
has
its.
it.
Crossplane has, like, isn't there like Como Plane that does a web UI for Crossplane?
Yeah, okay. Crossplane has it as well, yes.
And Kyverno has a UI for Policy Reporter, and Argo CD has a UI.
Yeah,
so why do
I'm
we need
realizing
a UI?
that probably my statement that not every tool has a web UI is because I never looked for those. Okay, Flux. I got
Flux
you.
has one now, but
No,
has
it
one
doesn't.
with a headlamp.
It has an extension in something.
No,
A
headlamp gave it a UI.
No, that doesn't count. Doesn't count.
So why do we need? Oh, okay, we don't need it, but why do we have it as a choice to have if every tool has a UI, why do we need a big UI?
Because it's more user friendly, right? If you're expert in something, yeah, of course you write code, right? You don't drag and drop stuff if you're a developer, right? If you're an operator, you execute commands. Of course you do that, right? But it's very friendly for people who should perform some operations without that being their core competency, right? I myself, when I faced with first time I was in front of AWS, I went to Web UI, right? Afterwards, I started using other tools and so on and so forth. But it's
a place for discovery.
Yeah,
it's a place
discovery and also
documentation, like education.
Exactly. And also, while I might have my reservations for using web UIs for operations, web UIs or graphical user interfaces, to be more precise, are infinitely better for observability of any sorts, right?
Yeah.
Even kind of like, what is the status of my application than CLIs and
Really
so on and so forth.
Need a graph for observability stuff.
Yes.
And then, like you said, different personas, like having a way for VP to come on and click a button and see cost of whatever.
Exactly.
Cool.
So there is space for everything. Depends what people want, what people need, and so on and so forth.
Okay.
Anyways.
So recapping Backstage versus Port.
Recapping? I wasn't even there. How can I recap?
Because you know Backstage and Port, Victor. You don't need to.
I not recap of the episode, but my opinion.
Yeah. What's your opinion?
Port is much more user friendly and much easier and lower maintenance. Backstage can do anything anybody could ever imagine at the cost of some pain, but its community and momentum is so big and so fast that it is a sure choice, right? Because kind of it's probably one of the biggest communities in CNCF right now, or even in Linux Foundation. So kind of like if you're okay accepting more pain, it's a more safer bet.
Supported, yeah. Oh, supported and safer in that if there's a whole community behind it, it's not going to like the price isn't going to jump or.
Not only prices, but all the other big players, if they are either building their own proprietary something or they're investing in Backstage. So if you go to VMware or Red Hat or Syntasso, for example, we had Abby from last week, they're all putting effort into Backstage. So it's almost like Docker Swarm versus Kubernetes, which is better. We can debate as long as we want, but everybody gathered around Kubernetes. So that's probably more important part.
That's a good point. Do you have to know JavaScript to use Backstage?
To use or to make it do something?
To make it do something.
Yes, you need to know not only JavaScript, TypeScript. TypeScript, yes. Everybody loves TypeScript.
What I thought Port was really flexible in terms of what it can do. You said Backstage is flexible, but what can Backstage do that Port can't do?
Port is flexible in terms that it's not really, I mean, now it's growing, but it's designed to do something relatively simple, and that's relatively simple is highly extensible, and it does what you need it to do. Backstage can do anything, kind of like you can have a plugin that cooks coffee, right, for you. It's the scopes are different. So it's more extensible in terms that the scope of Backstage is world, planet, universe, Nobody
Since
knows.
it is
right?
the universe, why not build your whole platform with Backstage and have all the logic in Backstage?
Oh, we had those debates 30 years ago. Why wouldn't you do backend as a front end? Because it's bad. It's a portal. It's a web UI, right? That's what it is. It is web UI. You don't do everything as front end. There are things you do, things you don't, right? Backend is where you process stuff. You don't replace. So let me answer this question to you. You don't replace Kubernetes with Backstage.
Yeah. Okay.
There we
I
go.
also was just trying to get you worked out. I was trying to bait you.
I had a relaxing week in Miami, nice weather, short sleeves. There is nothing you can do to me. Soon I will go to England. I hate their weather. I will be grumpy as hell. Put me on stage back that time, and you will hear me yelling without you even insisting on it.
Okay, we did a great job of recapping, and now let's get back to demo land. Thank you.
Yes. So demo, yes. It's built, it's finished. It checked out the code. It generated a tag. It ran unit tests. It built an image and pushed it to the registry. It did GitOps things. By GitOps I mean it modified the manifest and pushed it to some Git repo, and then pushed it. That's the last part. And then, so that's all, right? Tested, built, pushed. And now we should have a new release running in production, and we can check that. If I go to my application repo, here we go. If I do git pull, we can see that it pushed something, right? The thing that matters is that here we go. It modified the definition of this application by updating the tag, right? This is what it did. I built this image. I updated the tag of that image, and I pushed those changes back to Git. And as a result, my application, which you need to trust me, I didn't show you that, wasn't running until a few minutes ago. Now it is running. Here we go. Pods are running for 3 minutes, almost 4 minutes, right? Because the pipeline finished, built, push, did whatever needs to be done. Argo CD picked it up, synchronized it into the cluster, and we have the application up and running. Until you just need to trust me that until now it was failing for the obvious reason there is no image. And that's about it about Argo events. And then we run the same thing over and over. Argo Workflows, yes.
Yeah.
Yeah, I was saying Argo CD, that was correct because I connected it to it. But yeah, in this case, Argo Workflows. Yes, and that's all about Argo Workflows.
All right, now the question is, who won the vote for our graphical user interface episode?
Yes, if I ever figure out how to get back to where I was, there is a screenshot I'm going to share. There we go. We had port Backstage, port 1.
No.
Congrats. No, Backstage 1. Backstage 1. This is cognitive bias. You see? No, I'm checking whether you're paying attention because I have a theory that sooner or later you will start behaving like me. You will stop paying attention to what anybody is saying in those streams. I was testing you. You passed, Whitney. You passed.
Then what will happen to the show if neither of us is paying attention?
Well done. We need to bring Abby. I have a plan. No worries.
The Nomad has a question, but I don't understand that question. Maybe you do. How would you handle a microservice?
Just as I did now.
Yeah.
I mean, the point is that the microservices, right, depends. I really dislike the idea of monorepo, I think, and we can fight on that one if anybody wants. You have them in separate repositories, trigger your pipeline that will do whatever needs to be done, building artifacts, running tests, this and that. Ultimately, it will push something to a repository where you define all the desired state of your whole system, changes related to the new tag of that microservice. Argo CD or Flux or whatever else you're doing or using is going to synchronize it into the cluster, and you will live happily ever after.
That's it.
But I probably misunderstood the question, so just follow up either in this show or if it's not related to any of the projects, just ping me. I'll send you a link and we can have a chat.
Sounds great. So now let's see Backstage.
Yes, Backstage.
I'll put your
I already
screen
installed Backstage while we were talking.
Uh-huh.
Yes. So what I did is actually I installed. I did two things. No. Yeah. Oh no. Actually, you need to do 57 things to run Backstage. But among many things that I did to run it somehow, I installed basically plugins from this repo. This is TerraSky. And you know who is TerraSky, Whitney?
Scott Rosenberg.
Yes, that's the one. That's the annoying guy
guest
from
last
Thursday.
week.
Not the guest, annoying guy. He has a bunch of plugins. Some of them were for Crossplane, and Crossplane was one of the choices. Some of them are for DevPod, Kubernetes ingester that puts everything coming from Kubernetes, discovery, Caverna, blah, blah, blah. Now, what is important about those plugins is that with those plugins, I don't need to create templates that you typically create, the components in Backstage and go crazy. I just started Backstage, pointed it to my cluster, and it discovered everything that can be done in that cluster, right? And it discovered that I can create something called app claim, I can create something called GitHub claim, I can create something called SQL claim. It evaluated what's in my cluster, gathered the schema, and presented it to me, right? So
And those
basically,
claims are all cross-plane resources.
yeah, in this
that you
case,
have
because I
running.
said filter it like this, but it could be anything in your Kubernetes cluster, right? You choose which parts of the cluster should be discoverable, one way or another, right? And then you do choose, and then you are presented with choices like name, namespace, owner, some are required, some are not, next. Once it's finished, it will not do anything with the cluster because that should be illegal. It will push changes to Git repo and say, I'm done, right? And then it will assume that you have some other process monitoring those changes and synchronize it into a cluster, aka Argo CD or Flux. So it interacts with the cluster in the read-only mode. It doesn't push back anything, right? Now, I will not do that right now because among other things, it also went to my cluster and discovered what's inside of my cluster, not like only schemas, what I can do, but also what is running. And if you look at here, you can see that CNCF demo app is already there. That's the one I showed you. That's the one that was new tag pushed by Argo Workflows and synchronized by the Argo CD. And then this is too big.
Can you prove it? Is there an age on it?
Huh?
Is there
an age on it? I don't know. I never
Okay.
checked the age. Probably.
Okay.
Crossplane resources somewhere.
Okay.
Show events. If it works, who knows? Blame Scott. Oh no, yeah, I will make it work. Heck, it doesn't. It discovered everything, and you need to somehow trust me that it discovered it, and I did not. No, actually, you don't need to trust me. Whitney, what is the chance that I would be putting manually those things? Tell me. Karen,
Zero.
what are
If it's not
statistical
efficient.
chances? If I had to configure this and tell it to this or that instead of it discovering, you would see it 3 boxes at top maximum.
True. It's true.
If you don't believe me, you need to get to know me better. Okay? I'm always least resistance. And it discovered it and shows graphs and resources and for some reason doesn't show events, but it does show the YAML logs and so on and so forth, right? It discovers things, it creates forms for you, pushes data from those forms to Git, and it discovers what is running in your cluster at runtime. It's brilliant. Thank you, Scott. That's it. That's the demo. We finished.
We did it.
No, we have guests. We haven't
Oh,
finished.
yeah. Not the episode, but the demo.
Yeah, the demo, yes.
I'm going to pull your screen.
Yes.
We're going to briefly say again, we chose a poor episode title this week. This is where we level set and say, what are we going over this week? It's specialized templating is what it's called. It's not really that. These are 5 CNCF tools that each help separate concerns between the developer and operations in their own way. I'm interested to know, and I'll probably ask this during the Q&A part, are these tools meant to sit on top of what we've already built in terms of APIs and GitOps and cluster
Oh, that's a
policy?
tough one.
Or are they meant to replace them?
I'm
Yeah.
not falling for that one, Whitney. I fall every single time. And then I say something silly like the next episode is a gumbo. I'm not doing it again. Ask the guests.
Okay, guess be ready. I'm going to ask you that question. And meanwhile, is there anything you think else we should say to set up today, or shall we start introducing our guests? See who's going to
Start introducing the guests.
All right, let's do it. Ben, we're bringing you on first. Welcome, Ben. Will you introduce yourself, please?
Hello. Yes, my name is Ben. I'm based in the UK. I'm a principal engineer at Humanitech in the platform engineering space, working with lots of directed acyclic graphs. And I've been a core maintainer on the CNCF school project for a few years, which I'm looking forward to talking about.
Awesome. I'm looking forward to it too. Thank you so much. We'll see you shortly. All right. We have next we have Lesky. Welcome, friend. Will you introduce yourself, please?
My name is Alexei. I'm based in Lisbon. Yeah, I'm core maintainer of Werf. And within my company, I lead an R&D team that focuses on CI/CD and application delivery to Kubernetes.
Awesome. Cool. We'll see you soon. And next is Khan. Welcome, friends.
Hello, I'm Hank. I'm from PipeCD team, and I'm also organizer at CNCF Hanoi. I'm basically based on Hanoi, Vietnam, and Tokyo, Japan. That's working around, and happy to be here. Thank you.
Thank you. Awesome. We'll see you soon. Next, we have Sarah. Here you are. Welcome.
Hello, I've been for a couple of years. I'm also a staff software engineer at Series A.
Okay,
so check
restart.
this out.
We can't hear you. There's something very messed up on the audio. So
Restart.
so leave and come back.
It's because my cat.
No.
It's your cat. Cats are always causing trouble. Just please leave the stream and then join the stream again, and we'll have you do an intro. Thank you, Sarah. Sorry. And then last but not least, we have Will. Will, please introduce yourself.
Hey everyone, my name is Will. I am a product manager on the Microsoft Azure Incubations team, and I'm based here in very gloomy Seattle. And I'm also a maintainer on the Radius project, which I'm excited to chat with everybody a little bit more on later.
Great.
Thanks for having me.
Thank you, Will. Goodbye. All right. Sarah's not back yet, but when here she is.
Yeah.
Sarah, we're bringing you on. Here we go. Hello, Sarah.
Good?
Yes.
Yeah.
You're human again.
Beautiful.
Wow. Well, I wanted to be a robot for a little bit. Cool. I am a staff SWE at Adara. We just raised our Series A, and I'm a Porter maintainer, and it's a CNCF sandbox project. I've been a Porter maintainer for a couple of years now.
Awesome. Thank you so much for being here, and we can't wait for your presentation later. And please share your screen because we lost that with the restart. Thank you.
Sounds good.
Awesome. Okay, we're doing the thing. Do you have the timer ready?
I have the timer.
Ben gets an extra
And-
5 seconds since he told us what acyclic
Okay.
DAG
He can
stands
start
for.
immediately before I start the timer if he wants
Wait.
to just go for it.
So for application templating, you could use the score project. There's a big axes of different amounts of specificity that developers have in their applications and amount of degree of coupling to the runtime. And you can see there's various things here. What we're interested in is this yellow bubble in the center, this set of application specifications that don't require lots of domain knowledge. They have a stable and reliable interface that has just enough features that it does what 80% of the workloads need to do, and anything more complex can do what it wants, and supports a variety of runtimes. So we try to avoid the zone of domain knowledge at the bottom here, with developers writing Helm templates and K8s manifests and things like that, but we're still making sure that we're leveraging what the platform team can do to amplify developers. So what this looks like is where we come to the score specification. This is just the spec at a glance. It's a JSON schema. It has metadata at the top. It's got containers with an image, variables, some resource requests, a service declaration if necessary, exposing a port, and then an important resource dependencies on the bottom. And you'll notice that this is immediately intuitive. People can look at this, understand what the application is doing. You can see that this Postgres database is being used by this workload as an environment variable. You can predict based on the spec what the service probably does. It's exposed over the network. It's probably hosting an API, stateful API of some kind. So the score spec is an open source CNCF sandbox project. We're platform agnostic, container-based workload specification, and the goal is for developers to find that single file for their workload that works across multiple platforms. By workload, we mean something that is delivered as one or more containers. It may expose network ports that other services may need to access. It has some sort of dependent resources that must be provisioned for it, and it consumes some outputs or functionality from those resources. Anything else to do with container security, best practices, conventions, the how of making this work, we push down to the platform. It's not the developer's responsibility. The platform provides the best practices here. So this gives your developers lots of options for score implementations. They can take that file and deploy it to local machine, Docker Compose. We have a reference implementation that does that. They can deploy to Kubernetes. Again, reference implementation converts everything to K8s manifests. We've got a FlyIO runtime as a more out there version. And we've got folks building this for normal cloud providers like Azure, GCP, and the like. And we'd suggest people use this as an interface to their developer platform. Resources, things like Postgres, RabbitMQ queues that could be specific to your workload, shared across multiple things, network ingress routes, stuff like that. You can consume the outputs from these things in the environment variables, in mounted files into your workload, or as parameters into other resources, building a hierarchy of resources here. And so the iteration process, developer flow, looks like someone authoring a score file, and then either in their local testing or their CI pipeline, pushing this to a score implementation, which does validation, provisions resources, converts, interpolates things, lots of nice error messages coming out if it does the wrong thing, and then deploy this, and then iterate or promote it to the next environment like production. And if you want to find out more, Score is a CNCF project. We're on the CNCF Slack. There's a homepage, GitHub repos, and it's not just the JSON schema. We also provide documentation. There's reference score implementations I mentioned. There's a community. You can ask questions, get help building your own platform using this interface. We've got some shared libraries in Go that provide a lot of the bulk of these reference implementations and are good examples of how to do this securely and scalably. I probably don't have time to run the deep dive example, but this is what the CLI commands look like for one of our sample implementations. You can see there's an init, a generate. The platform engineer has provided some custom provisioner recipes that are being copied in to the state file, and the generate command dumps out a manifest YAML, which you can apply. You can then inspect the lists of your resources to pull out like the DNS name that was provisioned for your app and access in the browser. When not used to choose Score, don't choose it when you're tightly coupled to the runtime. If you specific hardware, specific networking, code-only Lambda functions, or granular control, don't do that. But for everything else, use Score.
Is that the end? Thank you so much.
Yes,
Ben.
he finished before the time. Brilliant.
Boring.
No gone for you.
Thank you,
No
Ben.
gone for you.
Appreciate
There we
you.
go.
I had my own timer on this side as well.
Cheater. Okay. Alex Ski, you're up next, friends.
It's not
Yeah.
Alex Key. It's Alex.
Alexei or
Alexei.
Alyosha. Alyosha.
Alyosha, yeah.
Okay,
Oh,
yeah.
Alyosha. Oh.
Let's go.
Go for
I will
it.
start with a broad definition of the product before going deeper. So Werf is a project-centric CLI tool that synchronizes the desired state from Git to the container registry and Kubernetes. It's not Docker build and Helm install. Werf is much more, and I will explain why. But before I do that, I want to say a couple of words about the project. We have been developing and using Werf in production for over 9 years, both for our clients and within our internal development teams. Today, Werf has a large user base, active community, and excellent documentation. Yeah, so what Werf is about? Werf is an all-in-one CLI. It eliminates manual steps and the need for users to interact with container registry and Kubernetes. Werf integrates deeply with underlying tools, embedding them directly into its core. Werf offers several key capabilities. I will now explain each of these aspects in detail. Go on. Let's start with the first key capability, Gitterminism. Gitterminus is not GitOps, but it shares its core principles, ensuring consistency and reproducibility directly from Git, while also managing source code and build configuration. Next, let's talk about how Werf handles builds. We will start with the basics. A Docker file consists of instructions, each creating a layer in the local cache during the build process. These layers, identified by unique content-based SHA-SUM, can be reused across builds. While this works well on a single host, Werf scales these benefits across distributed environments. By using the container registry repository as a distributed cache, Werf enables multiple builders to work concurrently. This is powered by a dedicated build backend agnostic layer. Users can choose between build and builder for secure, daemonless, and rootless builds, even in cluster, or building Docker CLI for common builds. After Werf takes care of tagging and incremental builds, the focus shifts to cleanup. Werf offers flexible cleanup policies, allowing users to decide which images to keep. While time-based and used in Kubernetes policies are straightforward, Git-based policies are more interesting and advanced. So, Werf tracks the commits associated with each image version, enabling cleanup based on Git history. Here's an example of a default policy that works well for most projects. For more details, I recommend checking out our analysis from 5 years ago and Werf documentation. Let's move to deployment. Our engine is called Nelm. Built in on Helm 3, Nelm improves key areas and rewrites others from scratch. It replaces Helm's problematic three-way merge with solid server-side apply. Let me highlight its main features. First, smart resource tracking. During deployment, Werf provides real-time progress, debug information, container logs, and resource events, all visible directly in your console. In contrast, Helm provides no real-time feedback, making it impossible to track and debug deployment. Second, resource deployment ordering. Werf offers a set of annotations to order resources in your deployment as you want. For example, use wait annotation to group resources and deploy them in stages, or use dependency annotations to build a dependency tree and deploy its branches in parallel. This approach is highly efficient for complex rollouts. Watch out recent CNCF webinar if you want to learn more about Werf deployments and Nelm. The final feature is application distribution with bundles. A bundle is a single entity that packages a Helm chart and its related images. Once a bundle is published, you can deploy it using Werf or any tool that supports Helm charts from ACI registries. You can copy it between container registries or export as a tarball, share it with USB stick, old school, but works well, and deploy it in air-gapped environment, for this example. Now let's take a quick look at how easy it is to get started with Werf in an existing project. Suppose we have an application that uses Dockerfile for builds and Helm chart for deployment. Add a Werf YAML, specify the images with existing Docker files. Then use resort Werf values in the Helm chart templates for the images, and that's all. Next, you can use Werf converge command to build the images and deploy the application to Kubernetes. Or
That's the end.
hands up.
You're
Hands
out.
up.
Oh.
Thank you so much.
Hey,
Well,
if you mentioned during one of your graphs that that's Doug, you would have gotten 10 seconds more.
oh, you're cheating. Yeah. Thank you so much. And if you have any questions about Werf, please put them in the chat, and we'll see you for the question and answer soon. Awesome. So next up, we have Gon. Hello, friend.
He's trembling now. He saw what happened to Alexei.
Okay, so my time is
for it.
start. Not
Yeah,
yet?
go
Okay.
for it. You
Okay,
don't have to
thank you.
speak.
Okay, so I'm here to say about the PipeCD, and the vision of PipeCD is the one CD for all, and it designed to overcome the challenge across our experience as a platform team to deliver various kind of application to different cloud with many different teams. And for people who new to PipeCD, basically PipeCD does what PipeCD and Argo do for Kubernetes. And the good point is we do for the other platform as well. And by other, I mean the serverless like Cloud Run or Lambda and EIC like Terraform, blah, blah, something. And it's a GitOps style continuous delivery platform that provide consistent deployment and operation experience for any application platform. So PipeCD has 4 remarkable strong points. Is multi-provider support applied. PipeCD the what FluxCD Argo do for Kubernetes and the platform as well. And it also designed to easy operating multi-cluster system. PipeCD provide a unified interface for different application platform, easy to build pipeline without changing application manifest, and reduce the operation overhead by not requiring to install or manage any complex controller. PipeCD follow the control plane and agent pattern, which the agent is stored inside the target cluster. The agent of PipeCD only make the outbound request, so it's safe, not sharing any credential outside the cluster. And also PipeCD designed to work with multi-application from multi-project in a scale organization. And in our company use case, PipeCD can handle more than 4,000 applications with thousands of deployment per day with only one single shared control plane. And this is the base abstract idea of PipeCD architecture. We have 2 component control plane and the agent we call the PipeCD. The control plane is a centralized component managing deployment data, provides gRPC API to connecting with the PipeCD agent, as well as the web functionality of the PipeCD UI. And the PipeCD is just a single binary component. You can run it anywhere you want, in the pod, in the serverless lab, and anywhere you want. PipeCD architecture have to separate the workspace of the platform team and the developer team. The platform team can focus only on the maintaining control plane, while the developer team who understand the application has the responsibility of installing the PipeCD agent along with their application and define the way the application should be deployed. And next, I will give a quick demo of PipeCD in the real life use case. Suppose we have this deployment and service, basically the Kubernetes manifest, and we have here is the application configuration which required by PipeCD. And let me edit this one to trigger the deployment. Okay, so normal use case just like this, and we create a pull request. And starting from here, I have a feature of PipeCD which I want to show you. We call it sprint preview. Basically, it's the feature that will show you what actually would be changed on your cluster after, even before you merge the manifest chain to the main branch. Just wait a minute before we can see the output. And while this time, I will show you the application configuration of PipeCD. We can see here is the pipeline state. We define what should the PipeCD deploy your application. We have here is blue-green progressive delivery pattern, and we have something like canary run out 100% traffic routing with approval for manual checking, primary run out, primary traffic routing, then canary clean, just normal blue-green things. And we have here is frame preview output, just like I talked before. We can see here the update, what would be changed if we merge this one. and we move this one. Okay, good. So we can move here. Basically, PipeCD follow the pool model, so we have to wait until the PipeCD can fetch the command, the update from the deployment chain. And I want to show you a little bit about the application
No, you
details of
won't.
PipeCD. Oh, okay.
Oh.
On time, sorry.
That was really great. Thank you
Yeah.
so much. And we'll see you shortly for question and answer parts. Bye. All right. Now it's Sarah. Here we come. Hello, friend.
Tell me the audio is still good.
Yes, it is.
It's good.
Oh,
Yeah.
It's
I've
good.
been
Go.
blessed. Okay, cool. Hi, we're going to talk about Porter. So Porter is a cloud native, tool agnostic, and supported from maintainers from a diverse set of companies. I'm pretty lucky that I get to say that all of my maintainers are from different companies and they're all volunteers. No company pays. Might be a bittersweet thing too. Porter is a sandbox project in the CNCF and was made by developers who experienced the problem of trying to glue multiple DevOps tools together and trying to get them work in large-scale enterprises. So people like Jeremy Rickard or Carolyn Van Sleek went and said, hey, Microsoft's having this problem where we have a bunch of like DevOps tools and we try to get them to play nice together and they constantly break. They're kind of glued together by like bash scripts and hope and prayers. So we take all these like disparate pieces and enable developers to use best practices, no matter the technology, wrapping them into an immutable container image that allows you to deploy your application, run your pipeline, or set up your system the way it was intended to be used. We also build upon a cloud native application bundle specification, so you can check it out on cnab.io. That's an open source specification that extends the OCI specification. How many times can I say specification? So this is an example of a Porter bundle, which is defined in YAML because of course it's in YAML. You can have Porter pull credentials from a local file, an environment variable, or your secret store like Vault or Azure Key Vault. And those credentials are only injected in runtime. We don't store them anywhere. We just come and grab them whenever we're deploying the application itself. Porter has the concept of these things called mixins, which are extensions that tell Porter how to work with different DevOps tooling like Terraform, Helm, or even Kubernetes. Mixins are super easy to build. You can build it yourself. I built one for Spin and like wrapping the whole like Fermion cloud ecosystem 2 KubeCons ago. It took me like an hour. It kind of works. So you can do it yourself. It's as simple as like specifying a bunch of commands and just defining a Docker file. In the bundle, you have like different actions. We call them just Porter actions, such as install, uninstall, upgrade, or you can create your own custom actions. And you can see here, like for our install command, we have like, hey, run the Kubernetes mixin. Here's our manifest. We're going to set wait to true, so we wait that it like succeeds. And then we're going to capture all these outputs and then pass that into our next mixin, which could be whatever you want, whatever you're capturing that output of that Kubernetes service into. We also have the Kubernetes operator, which is in development, and we're looking for developers to help us with it. So come help. Basically, you can use the operator, you can use Porter to install the Porter operator into your Kubernetes cluster too. So it becomes like a fun dog fooding. Nice quotes. So the operator runs inside the cluster and allows you to deploy Porter installation into the cluster. Porter has a state store, MongoDB, and it just keeps like the installation metadata. And that state store Mongo can be inside the cluster or outside of the cluster. So it makes it kind of wacky. Like you can have like applications running outside of your Kubernetes cluster and then inside the Kubernetes cluster, and Porter can manage both of those. The operator is currently in development, like I said, but it handles automatically deploying new versions of bundles when a new version is pushed and update an installation through an integration like Flux. It also enables you to respond to events in your cluster by leveraging bundles in your pipeline and enforces isolating environments by limiting secrets and resource access within namespaces. No, do this. Okay, so the best way I've come across to show Porter to people is to do use cases, because it's a very ambiguous, amalgamous tool. Pick an A word and use it. So at Microsoft, Porter is used in a couple different ways. One is within Azure Marketplace. So because of how bundles are made, they're these like images that you can just pass inputs into. It's used within that marketplace or different marketplaces where your end user, your customer, can input their own credentials or like what their cloud environment looks like, and then spin up that environment within their own like cloud or organization. Another use case was within Microsoft Research, where Porter bundles were used to create the same isolated environment for researchers to input different test data in and see the varying outputs. This was really cool, and there's some papers on like Microsoft blog.azure whatever that shows that during COVID times, Porter bundles were like passed around and wrapped to be able to like test different like COVID research data stuff. And then at F5, Porter is being used to lower their cloud bill by ensuring that all testing resources are actually torn down after the test is ran, as well as taking the load off of their SRE and infrastructure teams by allowing them to make bundles of environments and best practices to hand to development teams. And if you close your eyes, this slide will look done. But if you don't, then it looks like this. And you can check out Porter on the CNCF Slack. We're at porter.sh. We have a community meeting every other Thursday. I talk really fast, so.
There it is. Haha. Thank you so much. That was fantastic. And I look forward to asking you some questions soon. Thank you. All right. If y'all have questions, please put them in the chat and we'll get to them. We have one more presentation and then our question and answer part of the show. So Will, last but not least, hello. Uh-oh, I think you're frozen. Talk to me. Oh,
No,
Hi, can you hear me?
Hello, yes.
Go for it.
Here you go.
All right, well, thank you. I'm here to talk to you about Radius. So Radius is a CNCF sandbox project that is primarily concerned with how you define and deploy an application. So in short, it's an application platform that allows you to define your application once and then deploy it to multiple environments. So how does Radius enable that? You can think about it in the context of these four sort of main pillars that we have within Radius. It encourages team collaboration by enabling clear separation of concerns so that developers can focus on coding the application while the operators focus purely on the infrastructure. And this type of collaboration and separation of concerns is achieved using swappable infrastructure definitions. So think Terraform or Bicep modules that are packaged into what we call Radius recipes. And those recipes are registered to your deployment target environment. And at deploy time, these recipes can be invoked to provision the necessary resources required to run your application. And because we provide this very structured approach to app development, app modeling, and app management, it results in constructing a very rich set of application graph data that can then be used to understand and visualize how all the components in your application are interconnected. And the best part about the Radius application graph is that it reflects what's been deployed. So it's always up to date, where now if you build an application using Radius, you have in effect a self-documenting application. And then of course, we're a CNCF project. We are cloud neutral. We want to be able to deploy applications across both cloud and even on-prem or local environments. And currently we support deployments to both AWS and Azure, in addition to kind of local Kubernetes clusters. So let's walk through a visual example to get a high-level understanding of what Radius does. So here we have a very simple sample application that has a front-end and a back-end container, and then each of them have their backing data stores. Now, Radius comes into play when I've completed development of my application and I've containerized everything, and now I'm ready to deploy it to a production-like environment for testing. So note, for this application, I've selected to use portable technologies like Mongo and Redis, and the container, the application is containerized. So this means I can target multiple deployment environments to run my application. Now, the benefit of Radius is I can create a single application definition file as a developer and use it to deploy across different environments that are provisioned for me by my operators, all without me needing to know the underlying infrastructure or fuss with the configs and setup. So for example, as a first step, I might use Radius to deploy to my local environment, where my operator might have set up local Redis and MongoDB generic kind of Docker containers for me as a part of the recipes available in my local environment. And I use Radius to deploy my application to this local environment, and Radius will help me provision all the necessary Docker containers to run my application. And then when I'm ready, I could take it to the cloud. For example, I take it to Azure, and within my Azure environment that the operator has set up for me, I have all the necessary recipes to create the resources that are needed to run my application. So in this case, the recipes will help me provision an Azure cache for Redis, and then also a Cosmos DB as the backing data stores for my application containers. And then if you thought AWS, well, you guessed it, AWS, similar story. The operator might have some recipes set up for my AWS environment, where instead of Azure Cache, I now have AWS Memory DB to drive my Redis data store, and then Document DB to drive my Mongo-based data store. And all this will be obviously hosted on the my Elastic Kubernetes service cluster. So because I don't really have time to show you a full demo, I'll just show you some screenshots. So on the left here is a screenshot of what would be the application definition. And you'll see, you know, very declarative within the Bicep language. Oh.
Thank you so much. You're going to stay on screen with us. That was awesome. Dag, everyone. Those were some great presentations. Yeah?
Oh, we have a cat joining us.
And a cat. For the second episode in a row. We have, if anyone has questions after those presentations, please put them into the chats. We're going to jump right into some of them. This one I think is literally meant for Tekton, but I think it's pretty relevant to a lot of different presentations right now. So would you recommend using a common Tekton file for all applications in an organization and give the developers only JSON to define service-specific parameters? So Victor, do you want to answer it through a Tekton lens, and we can let others talk about? Yeah.
I mean, I will answer it for Tekton, but I think it equally applies for, you know, whether you use Argo Workflows or Jenkins or anything else. The first answer is, I don't know, and you don't know either. You have your customers. Ask them. Ask the developers. Kind of. I think that the biggest mistake that we're all making is trying to guess what other people need, right? And any product manager will give you the same answer, right? Kind of ask your customers, figure out. They will give you the answer. Now, let's say that for whatever reason you're not allowed to speak with anybody, and I don't have the context of your organization. The only thing that I can say is that most of the time I saw teams do that, it failed, right? Unless you have very homogeneous, say, okay, there is only one type of application. They all use the same thing. They all want the same thing. And I create a common pipeline and let them customize it through some parameters of sorts, right? The problem with that approach, unless it's really everything the same, is that you end up with a monster, right? You end up with something that has infinite number of conditionals. And yeah, this is one pipeline, but if they say this in this parameter, then do this. If they say that, they do this, and so on and so forth. What I would rather do is create, and you can do that easily in Tekton, and you can do it in many others, create templates and say, this is how we build stuff. This is how we test stuff. This is how we do this. This is how we do that. And then then let developers assemble those templates, right? So they will not have to do the heavy lifting, but they can choose. Okay, I want to build and I want to test. I don't want to publish, or right? Give certain level of flexibility while still removing the heavy lifting from them. And this is the answer that applies only that in the cases I don't know the context, then we cannot ask.
And like at least Ben and Will's projects today both talked about having a single application definition that you can use regardless of what the destination is.
But I'm pretty sure that, and guests will correct me, right? You can still have different types of applications. So there are variations. Sometimes there is a database, sometimes there is front-end, sometimes there is back-end, right? If you try to cover all that with one something, I'm skeptical. But
Let's hear
I
it,
might be
Ben.
proven wrong. Let's hear
Yeah.
from Ben or somebody.
Yeah.
Yeah, I think that's part of one of the like traps of working with like evolving a spec over time as your needs thrive, because you end up too tightly coupled to the first app that you come across, and then you struggle to adapt it to the next thing. Like both score and and score and radius and the bicep spec are very similar in that way, that they have like a common set of schema that they support, that's general enough for almost any kind of app. Although, like with score, for example, we've had cases where people have asked to deploy score to virtual machines, and like don't know what that. There's a missing piece in the middle there, like how you convert to a very opinionated workload.
Will, would you like to add?
The only thing I would like to add there is, so we've come across this kind of question when we've first added support for Kubernetes as the underlying compute platform, but now we're looking to add other maybe even serverless type container runtimes into Radius to support deployment to those runtimes, and it's a very real challenge we have to solve, right? Like there's certain elements of an application that are common across the container platforms, and we try to support as many of those as the lowest common denominators, right? Like every single containerized application will need an image that drives the application. So those types of properties would be common across, but then we also want to provide sort of punch through the abstraction type areas in the specification so that users can optionally tap into the platform specific features that they might want to tap into. So it's definitely a mix of both, but we do have projects like Radius and Score do have that, model it once and deploy it multiple places type of tenant.
Awesome. Next question is about Werf. Does a standard Helm chart work out of the box with Nelm? And then also, can a Nelm chart work with a Helm CLI, or are the projects diverged?
Yep. Thank you for question. Helm charts, Helm templates, and Helm releases work well with Nelm and vice versa. Yeah, but without Nelm specific features as expected. Yeah. So
awesome. Cool.
Yeah.
And then here's a question. Do I need to use bicep in Radius? Is Terraform supported cross-plane or something more common?
Yeah, that's a very good question. One that we get a lot. Terraform is supported. So if you remember in my slide, I mentioned the infrastructure recipes. So you can package up your infrastructure code into recipes and leverage those at deploy time. So those infrastructure recipes, we do support Terraform modules to be packaged as infrastructure recipes. The only place where we require the use of bicep is if you, for the developer who's building the application definition. And we chose bicep mainly for the very rich kind of ecosystem that bicep has and the powerful kind of language specific functionality that bicep offers. So we have in bicep, we have a plugin in VS Code, for example, that can do verification and things like that. So the application definition is in bicep, but everything else that powers the deployments can be either bicep or Terraform.
Excellent. And then back to my question that I was asking before y'all presented. I'm curious. So those of you who don't know, the platform we're building as part of this show that's been ongoing based on choices that the viewers have made. We have Crossplane for building APIs. We have Kyverno for cluster level policy. We have Argo CD for GitOps. We have Argo Workflows now. We have, yes, that's all. Oh, and for GUI, we have Backstage. So my question is your tool, could your tool work on the platform we've built so far, or is it replacing one or all of these components? So, Con, can we start with you?
Okay, so if the question is have to replace anything from there, then gotta be like um we specific on CD things. So Argo CDs, we just do the same thing with Argo CD, but slightly more. We have more integration with CI things. So only Argo CD with the
So
same
Argo
things.
CD and Argo Workflows too, right? Based on your presentation.
No, workflow is more like CI thing, and we not just do any test build publics anything. We just do CD. So any CI finished, then
Uh-huh.
use some mechanism like even watch a PipeCD, then trigger the PipeCD, and the PipeCD check the rest from there. So that
Awesome.
would be
Thank you.
the thing.
Sarah, does Porter work alongside of our everything we built so far?
Yeah, so the simple way to describe Porter is you can give it all of your world and define your world, and it'll just handle building it for you every time and make it into an artifact. So you could give it literally anything, but we do have a demo with like Argo CD, Kubernetes, and Argo Workflows where it installs bundles into a cluster. So yeah, it'll work.
So if we wanted to bundle up our entire platform that we've built so far and hand it to someone else.
Yeah, and
that's
Porter
what we would use Porter
supports
for. Yeah.
DAGs, so you could have dependency bundles too. I had to throw
DAG.
this somewhere. I got you.
Dag,
Correct me if
that's
I'm
awesome.
wrong, Sarah, but in the demos that I'm doing, basically I have a bunch of shell scripts and commands. Basically, I could replace those with Porter, right? Did I get
Porter
it?
would wrap them. Like think of it as
Exactly.
like, yeah,
Not
exactly.
replace, but yeah. Yeah.
Do this.
I always joke that someone should use dancing as part of their 5-minute presentation. I think it could work with Porter. Yeah.
That's what I'm here for.
Does Werf work with everything we've built so far, or would it replace some elements?
It fits well. It's well in such IDP, so we can delegate distributed incremental builds. What else? Versioning, tagging, and cleaning container registry. Also, you can distribute application, and deploy it with Argo CD, because Argo CD works well with Helm charts in ASIA repository.
Right on.
Yeah.
Ben, could we use the score specification?
Yeah, I think so. Like
yeah.
we see a few different ways that work with platform teams, and leading on from the previous episode with Backstage and Port, like we have folks that use portals to generate an initial score file, embed that into a repo, and then drive the CI pipeline off that. But we also have developers that work with the score file in the repo directly and use that for local development and testing. So you get a high confidence that what you're testing locally is what's going to be the exact same environment variables and everything that pass through into your CD process. But we're definitely not as heavyweight as Radius and many of the other tools here. We're mostly focused on that common specification.
Got it. And Will.
Yeah, so I do think Radius would work well with all those other tools in your stack. It's definitely very complementary to a lot of what you're already using. In fact, Radius itself has a Backstage plugin. So we've built a Backstage. So when you install Radius, it actually installs an instance, a Radius skin version of Backstage to provide you the visualization of the application graphs. You might remember that screenshot I showed in my presentation at the end. That was of the Radius Backstage instance. And then I heard that you all use Argo CD. We're currently building support for GitOps, so Flux will be the first integration that we release here soon. But that paves the way for integrating with other GitOps platforms like Argo CD very readily. So I think it could be very complementary to the CD pipeline that you already have in place.
Cool. Another question I have, one of the many ways our show is flawed is that we pit technologies against each other that often can work well together. And so I'm wondering from each of you if there's another technology that's represented here today that you think your technology would work well with. And if so, what is it and why? So Sarah's making a face. Do you want to go first, Sarah? No. Who would like to go first? Anyone? I know it takes a minute to think through this question. Okay, Will.
I think for just my surface understanding, PipeCD, like you do CD kind of GitOps style deployments for beyond Kubernetes or beyond what Argo and Flux covers. Like we are building integrations with Radius with these GitOps style tools. So I think PipeCD might be something that's complementary, and Score. I need to take a look at your specification, but it could be very well that we have commonalities there and some areas for collaboration for sure.
We've done an experimental Radius implementation of Score, so we convert the Score spec into a bicep file with like recipes that we run at that stage to convert into the Radius template. But so we've done a version where like Radius is the deployment target of the Score spec.
Oh, cool. Okay.
That's awesome.
I'll see if I can take that up somewhere.
Yeah, I'd love to see it.
Would anyone else like to speak on this? Yes.
Yeah, I think Werf will work fine with Porter and PipeCD. So Werf can build images, pack Helm charts, and then can be deployed with these tools.
Awesome.
Yeah, I think so.
I say the same thought with Werf and Radius, and also we are on the way to make the PipeCD agent. If you all still remember the agent as a plugin architecture, so we can actually make like Argo or FluxCD or anything else as an engine for the CD things, and we can just focusing on the pipeline things. So maybe I mean it's more chance to comparison with other. I think so.
Sarah.
I was gonna say Werf, but just because I really like the slides. Yeah. And then you have like a bundle, and then like, it's turtles all the way down. But I feel like Score could be more complementary because it's not like as much as like we generate an artifact and it's like whatever you want to stick in that artifact and then you can do whatever. Or like PipeCD could be more complementary too. But I'm voting Werf just because I like the slides.
Awesome. I think we should wrap up the show based on time, and we don't have any more questions. So the last thing we're going to do is go back through each one of you in the order you came on, and you tell us, please, why we should vote for your technology to be implemented in next week's demo. So Ben, let's start with you.
Briefly.
Why should we vote for Score?
This Score allows you to stand on the shoulders of giants and share the same kind of simplified Score spec across multiple platforms without being too strongly opinionated, supporting closed source and open source, remote and local experiences. And the spec is predictable and intuitive, and you can just focus on building your app. Doesn't support everything, but gives you clear focus and control.
Awesome. Thank you so much, Ben. Goodbye. All right, next up is Werf. Please tell me.
As I already mentioned, in UIDP, you can delegate Werf incremental builds, content-based tagging, container registry cleanup, release management, application distribution, and one more thing. You can delegate it compliance across your company. Yeah, it's good tools for that. So vote and then try Werf. Vote, then try. Vote.
In that order. Thank you.
Vote for Werf.
All right. Next up, we have Khan. Please tell us, why should we vote for PipeCD?
Okay, so I think one of the strong point is not just Kubernetes but the other as well, and also is multi-tenancy support from very beginning, just like I said in the graph, just one single control plane for the whole company wise with different team, different platform, different target, and just one single things. So if you want something just simplicity, and you can just focusing on your application, then use PipeCD. And I think that's all. PipeCD.
PipeCD, thank you. Sarah, why should we vote for Porter?
Yeah, so I mean, Porter has been adopted by a lot of large enterprises. It's super developer friendly. I just redid like half of the getting started guides. So, and we have a pretty active community. So whenever you come across questions, we're there to help and kind of adapt Porter to whatever you need. But also, we have a cat as was our logo, and my cat showed up. So I mean, like, really, it's like it's meant to be.
It's
Vote
fate,
for Porter.
yes. Thank you, Sarah. All right, Will, why should we vote for Radius?
Yeah, so my closing remark is just, we all know cloud native applications are so much more than just Kubernetes, and Radius is here to help you with your application development journey. Like if the idea of define the application once and deploy it everywhere, and also the clear separation of concerns kind of speaks to you, then definitely vote for Radius.
Awesome. Thank you, Will. Goodbye.
Thanks.
For those of you wondering where and how to vote, you can look in the description of this channel. The vote is in the CNCF Slack workspace in the You Choose channel. Victor, do you have anything
what
to
do you want
add?
from me now?
Hello.
No, it's cool. I learned a lot. Though I haven't been using those projects as deeply as some others. So this was
You
really...
lit up at Porter. I saw you go like this when she talked about
No, I mean,
Kubernetes
when I hear
operator.
Kubernetes operator, there is uncontrollable reaction. Kind of, this is not me. That was not planned. It's just kind of, you say operator, and then my muscle just kind of like moves, kind of, right? I don't know. It's maybe. I don't know whether it's excitement or trauma. I don't know which one it is, but
Well,
it's a trigger word.
Thanks everyone who is here live. Thanks to all our awesome guests who shared their expertise today. Join us next week when we talk about miscellaneous projects, Victor's favorites, the gumbo of the CNCF. And then I would call it goulash more than gumbo, but who's counting? And then that's all. Please vote. The vote is open for 3 whole days. So even if you see a recording, as long as it's 3 days from, I don't know, Friday. What is today? Today's Tuesday, February 25th. So if you're hearing this before the 28th, vote. Vote. Goodbye.
Bye-bye.